Hello everyone, my name is Cavell, and today I will be talking about solving linear systems with two variables. So, the first method I'm going to talk about is method of substitution. What does that mean? Method of substitution pretty much tells us to solve an equation for a certain variable in terms of another. So, let's do an example. So let's say we have x minus 7y is equal to minus 11, and let's say we have 5x plus 2y is equal to minus 18. So a good tip that I have for students is look at the variables, look at the two equations, and see which variable is by itself, meaning which variable has a coefficient of 1, because that will make things work a lot easier. So if I look at the first equation, I see it's x minus 7y equals negative 11, and I see the x by itself. So that means I can solve for x pretty easily by simply adding 7y to each side. So here you go. We have this. We'll add 7y to each side. Now I'm left with x is equal to minus 11 plus 7y, right? So that's what substitution is. Solve a variable in terms of another. So now wherever I see x, I'm going to plug in this negative 11 plus 7y into the second equation. So if we look at the second equation, x is right here. So wherever we see x, we're going to plug this stuff in. So in that case, we'll have 5 times 11 plus 7y plus 2y is equal to minus 18. Now this equation is a lot easier because we only have one variable. We only have the variable of y. So let's solve for it. So let's distribute this 5. 5 times negative 11 is negative 55. 5 times positive 7y is plus 35y. And now the parentheses can go away since we just distributed, and we can add the y's. So this is just plus 2y. It's all equal to minus 18. Now if we simplify this further, we'll get negative 55 plus 37y, because 35y plus 2y is just 37y, still equal to negative 18. I add 55 to each side so I can get the variable by itself. I'll get 37y. Remember, the negative 55s and the plus 55 cancels out. So I get negative 18 plus 55. That's essentially saying 55 minus 18. And then I believe y is equal to 37, right? Let me just double check that. (7) 37, yep, I was correct. So now we have 37y is equal to 37, divide by 37 on each side, and I get y equals to 1. So far so good. Now if you remember the equation before, we had x is equal to negative 11 plus 7y, right? So then I could just plug in y equals 1. So x is equal to negative 11 plus 7 times 1. And I get x is equal to negative 11 plus 7. X is equal to negative 4. Now it's important in math to always check your answers, because why? I did all this work right here, and if at the end the answers don't match up or my answers are wrong, then it's just a waste of time, right? So I'd say it's pretty necessary to check your work. So how do we check our work? So let me just delete this first. So I have y equals to 1, right? and also have x is equal to 1. Or sorry, x is equal to -4. So now to check, I just plug these values back into the equations and see if they actually match each other, if the left side matches the right side. So if x is equal to -4, y is equal to 1, our first equation would be -4, right, minus 7 times 1. And is this equal to -11? I put a question mark there because we're still checking. -4 minus 7. Is this still equal to -11? Well, when we have a negative number subtracting a positive, that's the same thing as -4 plus -7, right? And we can see that -4 plus -7 is -11. It's equal to -11. There we go. We just checked. That means the first equation is fine with these values. Now let's check the second equation. So this is equation 1. Equation 2 tells us 5x plus 2y equals -18. So we have 5 times -4, since x is equal to -4, plus 2 times 1, since we said y is equal to 1. This should equal to -18, right? Put a question mark. We don't know yet. -20, right? 5 times -4 is -20, plus 2. 2 times 1 is just 2. This is equal to -18. -20 plus 2, that means we're going to move 2 steps to the positive direction. And we get -18 on the left side and -18 on the right side. Hence, we did get our correct answers. So at x equals -4, y is equal to 1. So now it's important to realize that when we're solving two equations or linear equations, we're essentially figuring out when do these equations, if solved into y equals mx plus b format, when do they intersect? So this information is telling us at x equals -4, y equals 1, these are where the two lines intersect if I were to put them into y equals format. So another way of solving this problem would be to make it into y equals format. And to do that, we'll have x minus 7y equals -11. 5x plus 2y is equal to -18. If I solve for y for the first equation, I'll get y equals to -11 minus x all over -7. For the second equation, I would have y is equal to -18 minus 5x all over 2. So if I plot these two lines on a graph, I will see that at x equals -4, y equals 1, that's where these two lines intersect. So that's just a little brief overview on solving system of linear equations by graphing. But for now, we're going to be focusing on substitution. So let's do another example. So second example we have is 7x minus 8y is equal to -12. -4x plus 2y is equal to 3. So if you look at this question, we can see that all the variables have some kind of coefficients. So in general, it doesn't really matter which variable we solve for. So let's just stick with the first one. And let's just solve for y. So we get 7x minus 8y is equal to -12, right? I'm solving for y. So that means I should get y equals to some blah, 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 right? So let's solve for it. So we have 7x minus 8y is equal to -12 minus 7x each side. Remember, I'm trying to isolate the variable y by itself. We get -8y equals to -12 minus 7x divided by -8 divided by -8. I get y is equal to -12 minus 7x all over -8. So far so good. Now I'm just going to delete this work, right? So we have y equals -12 minus 7x minus 8. So wherever I see y in the second equation, I'm going to plug in this stuff into it. So I have -4x. This is the second equation. Oh. -4x plus 2. What's y? Y is -12 minus 7x, all divided by -8. So all divided by -8, and this should equal to 3. Now, as you can see with substitution, the second equation is composed of only one variable. So we can definitely solve for it. So in order to solve for it, let's simplify. So we still have -4x plus distribute the 2, right? But we also realize that there's a -8 here. So instead of distributing 2, could factor these things, because this is the same thing as 2 over -8, -12 minus 7x. So this is the same thing. So this stuff right here is the same thing as stuff right here, right? Same stuff. So if I simplify this, I would get 1 over -4 times -12. Oh, just -12 minus 7x is equal to 3. Now it's important that when we add these terms together, we need to have a common denominator. So a common denominator for all of these could be -4. So if I want common denominator for -4x, I'd have to multiply by -4, right? So I'd have -4x times -4 over -4. This stuff can stay the same, right? All -4. This should be -12 over -4, right? Now, since everything is in terms of -4 in the denominator, I can essentially get rid of all of them. Now what I'm left with is positive 16x, right? Plus -12 minus 7x is equal to -12. So we get positive 16x because -4x times -4 is positive. Two negatives make a positive when you multiply them. So let's just simplify. 16x minus 7x, right? This minus this is just 9x, right? Plus -12, the same thing as minus -12. Or sorry, just subtracting 12, right? So this is all equal to -12, right? Now let me just move this a little bit further up. Okay. So now I add 12 to each side. I get 9x is equal to 0 because -12 plus 12 is 0. -12 plus 12 is 0. 9x is equal to 0, right? Then I just do x is equal to 0 divided by 9, or this is just equal to 0, right? So far so good. So now it's important that we find out what y is, because we found out what x is. So let's do exactly that. So let me just delete all this. So we get x is equal to 0. Delete. So we have x is equal to 0. Remember, in this equation that we solved for in the very beginning, right? We have y is equal to -12 minus 7x over -8. So we just plug in x equals 0 into this equation. So we get y is equal to -12 minus 7 times 0, because that's where the 0 is, all divided by -8, right? This stuff right here, this minus 7 times 0 just cancels out, so we just get negative 12 over negative 8. We could simplify this to 12 over 8, which simplifies to common factor of 4, right? So we get 3 over 2. So we get y equals to 3 over 2. So once again, it's important that we need to check our work, right? Checking our work is extremely important, right? So at x equals 0, y equals 3 over 2, we should plug it back into these equations, right? These two equations. This is 1, this is 2. We should plug these back into the equation, see if they are actually equal to each other on left and right side. So let's do that. So if we have 7x minus 8y equals negative 12, x equals 0, y is equal to 3 halves. Well, 7 times 0 minus 8, 3 times 3 over 2, negative 12. Is this equal? 7 times 0 is 0, minus, right? Minus 8 times 3 over 2. 8 divided by 2 is 4, so this is the same thing as saying negative 4 times 3. Is this equal to negative 12? Negative 12 is equal to negative 12. That's fine. So that's for the first equation. Let's do the second equation. We have negative 4 times 0, because x is equal to 0, plus 2y. Y is 3 halves, so we get 2 times 3 over 2. And does this equal to 3? We shall see. Negative 4 times 0 here is just 0, plus 2 times 3 over 2. We see there's a 2 in the denominator, so the 2 here and this denominator cancel. So we just get 3 is equal to 3. And yes, it is. 3 is equal to 3. There we go. So we just solve for x and y using substitution. We got x equals 0, y equals 3 halves. We checked our work. We saw that the equations are actually equal to each other, left and right. And that's it for this equation. All right. Let's do one more question. So we have 3x plus 9y is equal to minus 6. We also have negative 4x minus 12y is equal to 8. So let me just write that 8 a little better. 8. So before we even do substitution, we can see that all these equations have a common factor. So, well, not both equations have a common factor, but we can simplify this before we actually solve for the variables. So if we look at the top one, we can see that we can divide by 3 everywhere, right? And then we would get x plus 3y is equal to negative 2. And how are we able to do this? Well, if you think about equations, right, the left side is equal to the right side. So as long as we do something to both sides, the scale is technically still even, right? So if we think about this as a scale, right, that's what equations are, right? So if we do this, if we think about this, right, the scale is 3x plus 9y. This is negative 6. We're saying they're equal. So as long as we do the same, operations, we're divided by 3, then that means it's still equal. This will still be an equivalent, relation. So that's always a good way to think of equations. What does it mean to be an equation? What does the equal sign tell us? So automatically from the first equation, I get x plus 3y is equal to negative 2, right? Obviously, I'm going to solve for x in this case because x is already by itself. There's no coefficient. Well, there's a coefficient. There's a 1 coefficient, which is what we want. So in order to solve for it, we subtract 3y from each side. I get x equals -2 minus 3y, right? That's an important information, so I'm going to square that. And if you look at the second equation, so let me label these. We can see that we can also divide by -4, right? Because we're dividing by -4 everywhere. So that means the equation still stays the same. So I have x, right? -4x divided by -4 is just x. -12y divided by -4, just plus 3y, right? 8 divided by -4 is equal to -2. So now if we look at this now, we can see that we actually have two of the same equations, right? We actually have x plus 3y equals -2. X plus 3y is equal to -2. So what does that mean? Well, if we have two variables that we need to solve for, and we have two of the same equation, right? That means there isn't actually an answer, right? Because in this case, we simply have just a line. Now, if we solve for y, we would get -2 plus x all divided by 3 is equal to y. How did I do that? I did x plus 3y is equal to -2. I subtracted x on both sides. Oh, sorry about that. I should be getting that, right? So I should be getting 3y is equal to -2 minus x divided by 3. Y is equal to -2 minus x over 3. So as you can see, we just have a line. What does that mean? That just means there's infinitely many solutions, right? Because there's no parameters to be set to make this equal. So as we can see, if we just graph this, right, you'll just have a line that looks something like this, right? And then the slope is -x over 3. Y-intercept is -2. So there you go. Oh no, maybe something looks like this. -2 over 3. So as you can see, in this case, we don't have one specific solution, right? And our solution is actually many solutions, infinitely many solutions, because whatever value I plug in for x, I am going to get something for y. Okay? And that is all. Thank you. Goodbye.